Hey guys, welcome back to another video, and today we're going to be solving the Leet code question arranging coins. So I am going to be using Python to solve this, but before I solve it, I'm going to be explaining the theory behind the question. Okay, so you have a total of n coins that you want to form in a staircase shape, where every kth row may have exactly k coins. Given n, find the total number of full staircase rows that can be formed. N is a non-negative integer and fits within the range of a 32-bit signed integer. From the question, we're given the number of coins. So the number of coins is equal to n. Our task is to find the number of full staircase rows that can be formed. So let's say, I'll just draw 4 rows. So we have row 1, row 2, row 3, and then row 4. Okay, so now row 1 is going to have 1 coin, so 1. Row 2 is going to have 2 coins. Row 3 is going to have 3. Row 4 is going to have 4, and so on and so forth. So now, for example, let's say we're given 10 coins. So let's say n is equal to 10. Or actually, instead, let's just say n is equal to 5. So when n is equal to 5, the first coin is going to go over here. So the second coin, third coin, fourth coin, and fifth coin. So now we need to see how many rows are fully formed. So row 1 is fully formed, so that's 1 row. Row 2 is also fully formed. But row 3 isn't fully formed as we have 1 blank space. So the answer to n equals 5 is going to be 2. Similarly, let's say we have n equals, let's say 9. So in this case, we have 1, 2, 3, 4, 5. This is going to be the 6th one. This is going to be 7, 8, and 9. So row 1 is done. Row 2 is also done. Row 3 is also done. But row 4 is not fully done. So in this case, the answer is going to be 3. Now, we could iterate for, let's say our number was 10. We could iterate through each and every one of the numbers up to 10 and find out what the answer is. But this is going to be a really long process. So instead, we can look for some sort of pattern. So let's just write out how many coins are going to be there in each row. So row 1 is going to have 1 coin. Row 2 is going to have 2 coins. Then 3, 4, 5, 6, all the way up to, let's say, the answer, which is k. So if you look at these set of numbers, they're actually a series. The difference between both of them is 1. So they have a constant difference. So what we can do is, in order to find how many coins are there, we can just add up the series. So to do that, we can use this formula. So the sum of the series is equal to the number of elements divided by 2 multiplied with the first element plus the last element. Okay, so now let's substitute this formula. So how many elements do we have? We have a total of k elements. So it's going to be k divided by 2 multiplied by the first element. So in this case, the first element is always going to be 1. So we're going to do 1 plus the last element. The last element is always going to be k. So whatever number, so let's say we put k as 2. So if k is equal to 2, then the sum of the series is going to be 2 by 2 into 2 plus 1, which is 3. And that equals to 3. So what does that mean? So that means when we have 2 rows, we're going to be needing a total of 3 coins. So for 2 rows, we need 3 coins. So we currently have this equation which gives us the number of coins needed to completely fill k rows. So if this value is equal to n, which is the number of coins we have, that means that in this case the answer is going to be k. But we're not always going to have the row completely filled up. So in that case, we need to find whatever value is equal to or less than n. So we need to find the highest k value, which is either equal to or less than n. So to do that, the fastest and best way is going to be to use a binary search. in order to find the k value which is either equal to n or the highest k value which is closest to n. Now we're going to implement a binary search and see how that actually looks like. So as an example, we're going to take n is equal to 11. So we have 11 coins. So first we're going to set a left and right value. So in the beginning, we're going to set our left value to 0 and our right value to n. So in this case, 11. So let's draw a quick number line. So it's going to start at 0 and going to go all the way to 11. And you have all the numbers in between. Our first step is going to be to find the middle number. So to do that, we're going to add the right and the left. So 11 plus 0 divided by 2. So in this case, we get 5.5. But we only want whole numbers. So we're always going to round it down. So instead, we're just going to take 5. So 5 is going to be our middle number. And what we want to do with this number is plug it into this equation. So if you put s of 5, that's going to be 5 into 6, which is 30, divided by 2. So that equals to 15. So now 15 is actually bigger than n. We don't even have 15 coins. So now we need to go down. We need to look at lower values. So we're going to change the right to the middle number minus 1. So the left is going to stay the same, and our right is going to become 5 minus 1, which is 4. So now we're going to be looking from 0 all the way to 4. So 0 to 4. So the number in between right now is going to be 2. So it's 4 plus 0 divided by 2. So now let's plug in 2 to our equation. S of 2. So S of 2 is equal to 2 into 2 plus 1, 3. So 6 divided by 2, which equals to 3. So S of 2 equals to 3. Now 3 is way too small. We have 11 coins. So now we're going to move up. So because we want to move up, we're going to move the left to the right. So our left number is going to become the middle number plus 1. So our left is going to be 2 plus 1. So it's going to be 3, and our right number is going to stay the same. So now we're going to be looking in between 3 and 4. So what is the number in between this? It's actually 3.5, but we're gonna round down. So in this case, we're just gonna look at 3. So S of 3 is equal to 3 into 3 plus 1, 4. So that's 12 divided by 2, which equals to 6. Now 6 is also again too small. So now again, we're gonna move our left because we wanna look at bigger numbers. So now our left is gonna become 3 plus 1. So our left is going to become 4, and so is our right. Our right is also going to become 4. So we're only going to be looking at the number 4. So S of 4 is equal to 4 plus 1, which is 5, into 4, 20 divided by 2, which equals to 10. Now, we could look for bigger numbers. So because 10 is still smaller than 11, what's going to happen is we're going to move our left by 1. So our left is going to become 5, and our right is going to become 4. But the truth is, we already found our answer. 4 is our answer. We can't have anything bigger than that. So we can put a condition that when our left is bigger than the right, that means that we found our answer already. So now let's implement this into our code. We're first going to initialize two variables called left and right. So left is going to start off at 0 and right is going to start off at n, which is the total number of coins we have. Now we're going to put this inside of a while loop where while left is less than or equal to right. Now the second left becomes more than right. That means that we've already found our answer and we can break out of the while loop. Then we need to find the middle value of right and left. So to do that, we're going to add them and then divide it by 2. So notice that we're using this operator, and what that means is that it's going to round down our value so that we always get a whole number. So if we get 2.5, it's going to round it down to 2. Now we need to find out, so mid is going to give us how many rows are there. So let's say we got a mid value of 2. Now we need to know how many coins are needed to completely fill 2 rows. So we're going to put it in the function which we came up with. So mid into mid plus 1 divided by 2, and we get a whole number. So now if this value is equal to n, that means that those are the amount of rows that we can have to completely fill out all the coins. So then we're going to return that value. If our mid value is less than n, so that means that we can look for bigger values. So now we're going to be looking at a bigger range, bigger value of numbers. So to do that, we're going to move our left to the middle plus 1. So we're going to look at the right side of the number line, which has bigger values. But if our n value is less than the mid value, then in that case, we want to look at smaller values or smaller numbers. So to do that, our right is going to become the mid minus 1. So in that case, we have smaller numbers. Okay, now finally, as we go through this while loop, there's going to be a point where the left value becomes bigger than the right value. And when that happens, that means we're going to break out of our while loop, and then we're just going to return right. So I submitted it and my answer got accepted. Okay, and finally, thanks for watching, and do like the video if this helped you out, and also consider to subscribe for more videos like this, and I also post projects.